All righty. How are you doing today, folks? Good to see you all. Good to see you. Okay, so we are going one more trig equation video here, as we're going to spend a second day on this. Really make sure we have it hammered home. The trig equations we're going to work on today are a little bit tougher than the ones we dealt with yesterday. So the ones we had yesterday were just simple one-step equations, or they were ones that we could solve with quadratics. What if we had things that were just a little bit more? So for instance, what if I had something, instead of having the two trig functions squared, so can use some sort of Pythagorean identity. What if they were both still had an exponent of 1? When this happens, one of the things we want to do is we want to go ahead and separate the variables. So go ahead and separate them. Every once in a while this happens here. So we can't just turn them into a different thing because I can't get just sine and cosine. That one made it a little bit different. So when that happens, sometimes we have to introduce more roots to be able to clean it up and be able to determine which roots to actually work. And so we're going to introduce more roots, not less. We're going to introduce more roots, and then we'll go back and get rid of the extraneous. And so the way we're going to end up doing that is we're going to square both sides. So when we square both sides, we end up with sine squared x minus 2 sine x plus 1 equals cosine squared x. All right, I want you guys to do me a favor. Go ahead and pause the video and see if you guys can go about solving the rest of this trig equation. All right, well, if it was me, the first thing I would do is I would end up taking that cosine squared x and I would turn everything into sine. So sine squared x minus 2 sine x plus 1 equals, instead of cosine squared x, we'll make that 1 minus sine squared x. All right, so now we're going to get everything equal to 0. So I have 2 sine squared x minus 2 sine x. Notice the 1's will cancel out, so that's going to be equal to 0. So then you guys factored out the 2 sine x, and that left you with sine x minus 1. So we factored it out. Now we're going to do our zero product property. We're going to set each factor equal to 0. So 2 sine x equals 0. And sine x, oops, forgot the x there. Sine x minus 1 equals 0. That means sine x is 0. So I think about my unit circle now. When is sine equal to 0? And that would happen when x is 0 plus 2 pi n. Don't forget your 2 pi n's. Just remember, 0's on the unit circle, the fundamental period, but we are going to keep going around as we're dealing with the other values. And x equals pi plus 2 pi n. Over here, sine of x equals 1. And that means then that x is pi over 2 plus 2 pi n. All right, so now before we get going too far, we still want to go ahead and see if we can't link any of these up together, which we will be able to do. So if I'm looking at it here, here's 0, here's pi over 2, and here is our pi. But now we squared both sides at the beginning here. And since we squared both sides at the beginning, that means we run the risk of introducing roots that never should have been there. So what we have to do is we have to go back through and test all three of these roots back into our original equation and find out, do they actually work? Are they actually okay? So we're going to take x equals 0 and we're going to plug it into sine x plus 1 minus cosine. So we see where they're at on our root map here. We can definitely tie the 0 and the 1 together. We can link those together, but we have to make sure that we didn't actually introduce something that shouldn't be there. And by squaring both sides when we did at the beginning of the equation, we run the risk of introducing roots that shouldn't be there. So sine of 0 is 0, plus 1, cosine of 0 is 1 equals 0. We end up with 0 equals 0. So that means this root is okay. That one works just fine. We introduced the next one. What was the next one? X equals pi. All right, so let's try that one. Sine of pi plus 1. And we only need to check the roots when we square both sides like we did on this one, just to make sure that we didn't introduce something that was inappropriate. So sine of pi is 0 plus 1 minus a negative 1 equal to 0. And friends, we end up with 2 equals 0. Well, that's not true. So this is what we're talking about. This is an extraneous solution. This one doesn't work. So because we squared at the beginning, we run the risk of introducing roots that don't work. So we had one here that didn't work. We checked the x equals pi over 2. We've got to find out if that one works. So we have sine of pi over 2 plus 1 minus cosine of pi over 2. I just realized I changed the problem at the very beginning. Friends, that's never good here. So let's go back and just change that real quick. You guys are probably yelling at the screen, Williams, what are you doing? That makes it 3 pi over 2. Ah. So let me get rid of that. Let's change that to 3 pi over 2. Here we go. I'm going to say, all right, these usually have 2 answers here. So it's going, some doesn't look right here. Let's see here. That makes that a 3 pi over 2. 3 pi over 2. All right, we're good. Let's keep going now. Cosine of 3 pi over 2 equals 0. So sine of 3 pi over 2 is negative 1 plus 1 minus 0 equals 0. And I ended up with 0 equals 0. Friends, we got a great answer there too. So that one works as well. So that means we have 2 answers that work, but we had the one answer that didn't work. So we have to get rid of that answer. It didn't work. So now we look at it and say, all right, can we tie these together in any way, shape, or form? There is no way to do it. So then we can go ahead and write our answers here. X equals 0 plus 2 pi n. And x equals 3 pi over 2 plus 2 pi n. All right. So you got the next one, cosine x plus 3 equals 0. Why don't you guys go ahead and solve that? Off you go. All right, let's see how you did. So cosine of x plus 3 equals 0. So that means cosine of x equals negative 3. Now we got to think about our graph here. Remember that cosine only goes from 1 to -1. So cosine x equals -3? I don't think so. There is no solution on that one. Not possible. All right. Well, let's keep going here a little bit, friends. Right here we go. Notice on this one, I'm going to go ahead and start off. And I'm going to recommend, friends, that you go ahead and move that 2 sine x all over to the same side here. So what do we have? Plus 2 root 3 sine x. I'm going to move the 2 sine x in between since it has a sign. And we'll make that minus root 3. All right, friends, do me a huge, huge favor. Why don't you guys go ahead and pause it up, see what you guys can do with that, and then we'll come back and take a look. All right, let's see what you guys did here. All right, so we're going to plug in all our terms. 4 sine squared x plus 2 root 3 sine x minus 2 sine x minus root 3. So we're just going to factor this out here, see what we can come up with here. Looks like I got a positive root 3 here, and that makes this a -1. So that'd be a 2 sine x here, and a 2 sine x here. All right. So 2 sine x plus root 3 equals 0. All right, so it factors out really nicely. So now we get to go ahead and do our 0 product property here. We set each factor equal to 0. So 2 sine x minus 1 equals 0. And 2 sine of x plus 3 equals 0. So when we solve it here, we get sine of x equals 1/2. And we get sine of x equals a negative root 3 over 2. So we think of our unit circle now. When is sine x equal to 1/2? Well, that would be at pi over 6. Plus 2 pi n. And 5 pi over 6. Plus 2 pi n. What about negative root 3 over 2? Let's try that one. How about that would put us at x equals 4 pi over 3 plus 2 pi n. And x equals 5 pi over 3 plus 2 pi n. So next up, we got to go through, figure out, are there any values here that can link up together? We're going to draw our little map here. Pi over 6, that'd be right here. 5 pi over 6 would be here. And we have it here and here. Well, it's reflective. It has reflection symmetry. So it's reflective over the y-axis, but is there any rotational symmetry? In this case, doesn't look like it. So because there is no rotational symmetry, that means all 4 of my values can't be linked together. We just go ahead and leave them all alone and we just call it a day. That would be our final answer. So just get a little bit more practice at some of our solving equations in general. All right, wait. Now, sometimes you want to look to turn your two functions, if you have more than two, into a different function. I want you guys to take a look at number 4 here and see what you can do with that. All righty, let's see what you did here. So again, sine x minus cosine x equals 0. So it's like the first one we had. They're both linear, so we have to separate them then. But this time, I don't have to square them. I can, in which case, if I did that, I would introduce extraneous solutions. However, since there is no 1, there's no extra number tied in here, I could do this. I could divide both sides by a trig function. In this case, I could divide them both by cosine. So tangent of x equals 1. So where on the unit circle does tangent equal 1? Well, that would be at pi over 4. And 2 pi over 4. There's a reason we're going to be able to link these together, because remember, the period for tangent is actually 1 pi. So that means these two answers right here, in 1 second, they'll link together and be pi apart, because that's the period for tangent. So if I go and I link them together here, you'll see that rotation, that 180-degree rotation, that pi rotation. Notice, if I add pi, I get to 1. If I add pi again, I'll get to the other. They have a 180-degree rotation. And because of that, we can go ahead and link them together. And we need to link them together too. We want to just clean up our answer a little bit. So we don't need 2 answers here. When we go and write our final answer, we'll write it as just 1. So plus pi n. So this next one, let's do this one together here. And here's my little kind of thing for you on this one. You notice our angle isn't x or theta or something like that. It's actually what we call a multi-angle. It's a multiple angle. And friends, whenever we're dealing with a multiple angle, one of the things that's usually really good to do is treat it like a different variable. So instead of thinking of it as 4x, let's think of it as theta. So that way, instead of 4x, let's think of it in terms of theta, in terms of something that we know what we're doing. So cosine of theta equals negative root 2 over 2. Well, if that's the case, then theta on our unit circle would be 3 pi over 4. You can hear my dog in the background. She decided to get a little burst of energy and is running uncontrollably now. That's the fun little puppy stage. And also 5 pi over 4. She's coming back for another round. Now, before I go and I put my 4x back in there, I want to check to see if any of these link up. So I want to check, do my solutions possibly link up? Here's 3 pi over 4. Here's 5 pi over 4. And when we're looking at it, they do not link up together. So we can just go ahead and move on like normal. But we weren't ever dealing with theta. What we were dealing with on this problem was 4x. So we have to go through and put 4x back into our equation. So we put it back in to our equation. The reason why we had to check why I did the map first is if we can link them up, we want to link them up before we go and plug our 4x in, our multiple angle in. If they link up, we need to link them up first. All right, so 4x. Now we're going to get rid of that 4 by multiplying by 1/4. But that means on the other side, we're also going to multiply by 1/4. Same thing as dividing by 4. Because we want to solve for x. And notice what that does. It's going to change the period that we're dealing with. And it kind of makes sense because what we're really looking for there is a b value on our transformation. That 4x, that's a b value of 4. And 2 pi divided by b is what our period is. So it's going to affect the actual root of our answer, but also affect the period. So 2 pi times 1/4, that would be 2 pi over 4. And we've got to reduce that down real quick. So x equals 3 pi over 16 plus pi over 2. And when we multiplied the other one by 1/4, we ended up with 5 pi over 16. And 1/4 plus times 2 pi would be pi over 2. Biggest thing people forget to do on that one is they forget to multiply the 2 pi in by whatever that b value is that we're getting rid of, or divided by it. Well, friends, you can see the next one, 2 cosine 3x minus 1 equals 0. Why don't you pause the video and give that one a try and see how you do. All righty, let's see how you did here, friends. To begin with, 2 cosine of 3x minus 1 equals 0. So I'm going to start off by saying I'm going to let theta be equal to 3x. So 2 cosine of theta minus 1 equals 0. So that means cosine of theta equals 1/2. So if cosine of theta equals 1/2, that means that theta is equal to pi over 6 plus 2 pi n, and theta equals 11 pi over 6 plus 2 pi n. So we check to see, can we link them together? So we're looking at it here, trying to figure out, do they link together? And we end up with, let's see here, pi over 6. Nope. Not my day today, apparently, because apparently I'm going to be just coming up with the wrong answer here. 1/2 would be pi over 3. And 5 pi over 3. There we go. I feel a little bit better about that. Hopefully you guys feel a little bit better about that too. I'm telling you. That's what I get. All right. So pi over 3 and 5 pi over 3. Plug them in here. And if you're looking at it, again, they're not going to link together. So since they don't link together, we can go ahead and just proceed with both answers. And so we're going to set 3x back in for theta. So 3x equals pi over 3 plus 2 pi n. 3x equals 5 pi over 3 plus 2 pi n. And then we're going to get rid of that 3 by multiplying it by 1/3. So x equals pi over 9 plus 2 pi over 3 n. X equals 5 pi over 9 plus 2 pi over 3 n. All right, why don't you guys pause the video, see if you guys can't take a little gander at that next one and see what you come up with. All right, so this one's a little bit different, right? Well, still the same idea here. I'm just going to let theta be equal to x over 2. So that means 3 tan of theta plus 3 equals 0. So tangent of theta is equal to -1. So we think here, when is tangent on the unit circle equal to -1? Well, that would be at 3 pi over 4 plus 2 pi n and at 7 pi over 4 plus 2 pi n. So when we go ahead and we set it up here, all right, we have an angle here and we have an angle here. I never actually wrote those angles up here. Those link together. They are pi apart. So pi, pi. So we can actually go ahead and bring them together as one. So theta equals 3 pi over 4 plus pi n. Now we go back and we plug x over 2 in for theta equals 3 pi over 4 plus 2 pi n. Oh, plus pi n. So we have to link it together before we put it back in there and we deal with the multiple angle. But now that we've got the multiple angle back in, now we can go ahead and get rid of that divided by 2. We're going to multiply both sides by 2. And we find out then that x is 3 pi over 2 plus 2 pi n. All right. So hasn't been too terribly bad there. We got one more to get going here and try a little bit. So why don't you guys try our last one? Number 8, cosecant squared x minus 3 cosecant x equals -2. Why don't you go ahead and pause the video and let's see how you do, and then we'll come back and take a look at it. All right. All right, friends, last one here. So we have cosecant squared x minus 3 cosecant x equals -2. So again, we want to go ahead and set it equal to 0. So that'd be a +2. And we're back to quadratics. We've got to go ahead and factor it. So if I'm factoring it here, I'm looking at this. I have cosecant squared minus 3 cosecant plus 2. So that'd be cosecant minus 2 and cosecant minus 1. So cosecant squared, this is going to end up becoming cosecant x minus 2 and cosecant x minus 1. Cosecant x minus 2 equals 0. And cosecant x minus 1 equals 0. So when you're going through and doing this, if you need to, friends, if you have to do the, well, let's do it. Let's first solve it here. Cosecant x equals 2. And we'll get to it. And cosecant x equals 1. If you need to, if you want to go ahead and flip it, you can always think of that cosecant x equals 2 and turn it into sine of x equals 1/2. If you're still working on the unit circle a little bit. You can turn them back and do the reciprocal functions if you need to. If you don't need to, don't worry about it. So let's see here. Cosecant x equals 2. So that's going to be at pi over 6 plus 2 pi n. That's going to be at 5 pi over 6 plus 2 pi n. And cosecant x equals 1, that's going to be at pi over 2 plus 2 pi n. So now we got to figure out, do they link together? We can, well, that's pretty. Did not mean to do that, whatever I did. All right. So pi over 6, that'd be here. 5 pi over 6 is here, and pi over 2 is up here. Well, friends, there's nothing on the quadrant 3 and 4, so that means there can't possibly be any rotational symmetry. So in that case, that is our final answer. And friends, that brings us done for the evening. So anyways, I'll see you in class tomorrow morning. We'll spend more time talking about trig equations and solving them, and looking forward to seeing you then. Take care.